Hello children, welcome to channel Sube. Children, today I am going to discuss question number 39 of MCQ part of 2019 Physics new syllabus paper. As shown in the figure, an incompressible liquid flows steadily through a horizontal pipe. This one is the horizontal pipe. Two narrow vertical tubes are fixed at two places on the horizontal pipe where the cross-sectional areas are capital A and capital 2 times A. So these liquid through horizontal pipes, they are narrow vertical pipes. These are vertical pipes. There are small vertical pipes, narrow vertical pipes, where the cross-sectional area is A here, cross-sectional area is 2 times A here. They have shown it here, but it doesn't matter, the same, since these lines are parallel, same. So if the height difference of the liquid columns in the two vertical tubes is h, flow rate of the liquid through the pipe is, and they want us to find flow rate. So let's fill the pipe with liquid so that we can understand the story. So up to this level there may be the water level. So here up to this level there may be the water level. I will explain how I decided it, the level. So let's think the water columns are like this. The tube must be like this. This tube also, right? Okay, doesn't matter. So let's try to fill this, right? And you have to draw streamlines here like this. Streamlines you know, don't you? If you have learnt the lesson Bernoulli equation and Bernoulli theorem, you know what are streamlines. So these streamlines we can draw like this. So we take 2 points just at the bottom of these vertical tubes, 2 lines, 2 dots, and 2 points in the same streamline. In the same streamline, 2 points we consider, but they must be at the bottoms of these vertical tubes. So first of all, let's make clear. First of all, let's identify what they want us to find out clearly. Flow rate of the liquid through the pipe. Flow rate, not the velocity, not the speed. What they want us to find is flow rate. So suppose the velocity here is V2, output velocity is V2. So the water column leaving the tube, this horizontal tube, let's take as like this, per second. The water column leaving the tube per second. That's what now we have drawn here. The water column leaving the tube per second. So this is the water column leaving the tube per second. So if the velocity is v of it, so So we have taken the velocity as v2, here v2. So if the velocity is v2, what I have drawn here, the volume per second, this volume, this what I have drawn is the volume per second. So what is the cross sectional area? 2 times A, 2 times capital A, they have given capital A and 2 times A. So what is the length of this column? What is the length? Because the velocity is v2 and we have drawn the column per second, the column that is leaving per second. So this length must be v2 therefore, because what is the definition of, what is the meaning of v2? The distance per second. So this one is the distance per second. So therefore this length must be v2. So the volume, how to find out the volume? Volume per second. So we need volume per second. To find out the volume of a cylinder, we have to multiply the length and cross sectional area. So 2a times v2 is this volume per second. So this is the thing we have to find out. This is what they call flow rate. This is what flow rate is. So we have to find out v2 to calculate the flow rate. So if we found v2, no problem, by multiplying 2a, just we can get the final answer. So that is the path we are going to follow. So now our goal is to find out v2. So they have given the difference of these water columns, the height, difference of height, as simple h. 2 vertical tubes is the difference, height difference of the liquid columns they have given as simple h. So we can use it, simple h. So now you have to think about why there is a height difference. Why there is a height difference? So you have to use the theorems what you have learned. At this point, let's suppose the velocity is v1. At this point, let's suppose the velocity is v2. v2 is smaller. I'll explain why that. So that is the velocity we have taken here as v2. So so the cross-sectional area here is capital A. Cross-sectional area here is 2 times A. So it is greater. So there is an equation A1 V1 equals A2 V2. Do you know that? You must know that. You must know this equation, because this is not Bernoulli equation. This is just the volume per second. This one is the rate, volume per second. That is what we have written here, volume per second. Cross sectional area times velocity or speed. So initial the velocity at point 1 is this one, must equal to volume per second at point 2 here. because no water is leaking from this tube, no water is coming into the tube. So the amount left this place per second must arrive here per second. So therefore we can write this equation. So this equation you must remember this equation. This is a simple fluid equation. So we can substitute here for A1 because they have given it as capital A. So let's substitute here. A1 is just A, so V1 equals A2 is 2 times A, then V2. So A cancel, V1 equals 2 times V2. So we can write V1 is greater than V2 by 2 times V2 is equal to V1. So V1 is greater. So therefore now we know V1 is greater. At this point the velocity is greater, that is why I drew this arrow longer than this arrow. So now let's go to the Bernoulli theorem. So in Bernoulli theorem, what is the equation? Pressure energy, that is the pressure, and half, not mv squared, we write rho v squared, the kinetic energy of unit volume, plus not mgh, we write rho gh instead of that, the potential energy of unit volume equals constant. So this one is the pressure energy we say. So this one is the kinetic energy of 1 cubic meter of this liquid, 1 meter, 1 meter, 1 meter. So the kinetic energy. So this term is the potential energy of unit volume, that means 1 meter, 1 meter, 1 meter volume, cubic meter, the potential energy of that is the term of Bernoulli equation. So here the points are at the same horizontal level, this point, and let's use another color, otherwise you can't see. So this point and this point, those points are at the same horizontal line. Therefore there's no potential difference here. Therefore we can take the kinetic energy change. So therefore we can brief it like this. The kinetic energy has been changed because the velocity has been changed, V1 to V2. So the change of kinetic energy we can calculate, change of kinetic energy. So must be equal to the change of potential energy, Why? We know change of potential energy. That is what we are going to do now. We know when the velocity increases at a point, what happens? The pressure decreases. From that early equation you can understand it, because the pressure plus half rho v squared equals kinetic energy. I don't write the rho gh part because these 2 points are at same horizontal level. So when this kinetic energy increase, what happens? The pressure must decrease to maintain this equal sign and to be equal to the same constant. You know that. So pressure must decrease. Therefore in brief, just we keep in our mind, if the velocity just increases, what happens at that place? The pressure decreases. So velocity we discussed earlier is greater than V2, V1. So therefore V1 is greater than V2. So the pressure must be lower at this point, the P1. So the pressure at this point must be higher. The pressure at this point must be higher because the speed is lower. That is why we can decide that this height is greater than this height. So suppose this height is capital H1, this height is capital H2. So we can write, since this paper is a multiple choice question paper, you don't have to write these things, but for understanding we can write A1 is smaller than A2, therefore V1 is greater than V2, therefore pressure P1 is smaller than P2, therefore capital H1 is smaller than capital H2. Because since the pressure is smaller, then this height also is smaller. Why these vertical tubes are fixed? To identify the pressure, to measure the pressure. So the pressure, the reading gives an idea about pressure. So now I explained why I have drawn this diagram like this. This height shorter, this height longer, taller. Now you can understand. I explained it like this very clearly. So these are the logics what we used to draw this diagram like this. So now what we have to do is, as I said, this principle, kinetic energy change must be equal to the potential energy change. So let's write now that kinetic energy change is, normally we write kinetic energy how? Half mv squared, but I explained, and also you must have learned in that lesson, we use always the kinetic energy of a 1 cubic meter, not the mass we use. What is the mass of 1 cubic meter? You know, rho equals, the density equals mass divided by volume. So here volume is 1, volume is 1, then rho equals m, therefore m equals rho. So we can substitute m instead of m, rho. You know all these things, in the lesson you learn these things. So this is the kinetic energy of 1 cubic meter of liquid. So rho v, which one is the greater? V1, because we have decided now V1 is greater than V2. So V1, let's write V1 squared minus half, the same way, rho V2 squared. What is this? The kinetic energy change must be equal to the increase of potential energy of 1 cubic meter, because the pressure increased. So what is the potential energy? What is the potential energy? We know mgh. Mgh is the potential energy. So instead of m, what we write? Rho gh, because the volume is 1. Therefore rho equals m equals rho gh. So potential energy gained is rho gh. So this is the equation. Kinetic energy change is converted to potential energy gain. So this one is the kinetic energy loss, that is equal to the potential energy gain. That way also we can say. So we can then take half and rho because common, v1 squared minus v2 squared. We have to simplify this, rho gh. What we are going to do actually, we are going to find out this v2, that is the goal. Then rho cancel, both sides have rho, so half, instead of v1 squared we can substitute what we have found already, this one. No, the above the equation, this one. v1 equals 2 times v2. So 2 times v2 squared of total thing, v2 squared, so gh. Then half, 2 times 2 means 4, then v2 squared minus v2 squared, like that. This v2 we just leave as it is because we want v2, here you see v2 we want. Therefore for v1 we substituted from here because we want to eliminate v1. Then let us simplify gh. Then v2 also we can take out of the brackets, v2 squared divided by 2, then 4 minus 1 here, gh. Then 4 minus 1 is 3 v2 squared divided by 2 equals gh. So what we want is v2, v2 squared is 2 divided by 3 gh. Then v2 equals root 2gh divided by 3. But what we want, the final answer is this one. We have to multiply it by 2a. Then let us do it. 2a times this v2 means root 2gh divided by 3. So what is this? Flow rate, not v2, not anything else. What they want us to find out, that is what we have now obtained, flow rate. 2a times 2gh divided by 3 root 2a times this one, the fifth one. This one is the answer for this question. So children, I used the short method here without writing the whole equation of Bernoulli's theorem, but finally I decided that you may not understand because you are used to just substitute to Bernoulli equation. Therefore I am going to show you how to do that using the Bernoulli equation without using the short method that I used in early calculation. So here the same figure I have copied to this side. Now I am going to show you how to calculate using the Bernoulli equation. What is the Bernoulli equation? P equals, not P1 plus half rho v1 squared plus rho gh equals rho gh1, say, then P2 plus half rho v2 squared plus rho g h2. This is the equation usually you use because we apply Bernoulli equation to point 1 and point 2 and we get this part, and then for point 2 we get this part. So we equate those parts because this part equals to constant, this part also equals to constant. Therefore finally we get the equation like this. This one is familiar with you. So what is this h1? What is this h2? To the points of the streamline, the height, that is the h1 and h2. So we have to take a zero potential level for that. So this one is 0 potential level, is the reference level. Potential energy 0 at this level. So relative to that level we have to measure the height to this point 1. So that is what h1 here. Then to the point 2 you have to measure the height h2, that is the h2 here. So you see this h1 and h2 are equals here, since this streamline is exactly horizontal. Therefore instead of this h1, instead of h2 we can write h1 because they are equal. So these parts, these terms cancel each other. Therefore for horizontal streamlines we don't use this rho gh term, this term cancel like that. Therefore the only these 4 terms we get to simplify. So now I think you can understand that. So now let's apply these values. We know already V1 is greater than V2. Therefore we can write like this: half rho V1 squared minus, we take this term to this side because we want to simplify this and find V. Therefore half rho V2 squared equals P2, then this term we take to right side minus P2. So this is the second step. So we can do the previously what we did in the same thing. Half we can take out, rho we can take out, and V1 squared minus V2 squared. That part goes the same way, but this part, what is P2? P2 is the pressure, this one, pressure. How do we find it? Because we have a pressure meter here. A water column is a pressure meter. So what is P2? How we get the pressure from a water column or mercury column? If it is mercury, we know this pressure at the bottom is H rho g. H rho g, rho is the density of this liquid. So the same way we can use these vertical columns, vertical tubes to measure the pressure. So P2 here is what then? Capital H2 rho g, the same liquid rho, the density is rho here, and the density in this tube also rho. Therefore H2 rho g, H2 rho g. H2 means it has not been given in the question, I used it like this, H2 and H1. So but you can use it. So H2 rho g, then minus here H2 minus, then H1 here P1, not P2, because this one came to this side. So P1. So H1 rho g, clear, isn't it? H1 rho g, the pressure at P1, the pressure P1. So the pressure P1. So now here also you can get rho g part out because common H2 minus H1, then half rho V1 squared minus V2 squared. So rho cancel, the same way rho cancel. Then instead of H2 minus H1, what we can write? H2 minus H1, what is, you can see from the diagram, H2 minus H1, this simple H, the difference they have given, this difference they have given H2 minus H1, simple H, it is equal to simple H. So we can use it. So the path is a little bit longer because you have to write all these things. So here simple h comes, simple h, then g, then half v1 squared minus v2 squared. So that equation is what we have written here. Half, before substituting this place here, you see this place, row cancel, half v1 squared minus v2 squared gh. So after that you have to substitute from that v1 equals to v2, or otherwise v1 equals 2 times v2. So from this step, so from here you can follow the same path that we followed earlier. So now I think you can understand if there are any doubts. So from here you have to now go to this part. So I explained that also. I decided to explain because I thought that this video may be useless if you are used to this method, but I used a shorter method. Just I used directly the change, this one, the change without writing this change of kinetic energy, just without writing this pressures, directly I took this part. I jumped from here to here. So therefore I explained that also now. So I think now no doubts are there, you can catch this. So thank you very much again, see you tomorrow. So children, I think you can understand. I explained so that you can understand, I believe. So thank you very much for watching my videos, children. Keep watching again and again. So see you tomorrow. Goodbye.